Let me flip this around. Let me flip this to me. Now, I know this is an unusual subject, but it's real. Okay, and with that being said, I am going to say this. My hair is kind of sticking up. Hello. Hello, wherever you are in any part of the world. Hello from my heart to you. Did you know that they were looking for dark matter inside the brain? Did you know that? Now, I did show before that there was a, let me get this. Back in 2013, they wanted to do mapping of the brain. Mapping of the brain. I released the video where the guest speaker said they were going to do brain mapping. That's what they said, brain mapping. Hello, everyone. They were going to do brain mapping. And I'm trying to find that tab. It just, oh my goodness, Gina, you went out of that tab. I went out of the tab. But okay, but anyhow, look at this. So they're talking about, they were looking for dark matter in the brain. They are the neurons which don't fire in response to any stimulus tested. Silent neurons are related to the concept of sparse firing, which is believed by some to be a general principle of brain organization. Sparse coding means that given a stimulus only activates a small number of neurons. So they had these things where they were mapping the brain. Hello. Hello, wherever you are in any part of the world. Hello from my heart to yours. Okay. So you say, oh no, they're not going to do 3D mapping of the brain. They are doing 3D mapping of the brain. Look at this. Look at this. So that's what they did. Whole brain 3D mapping of human neural transport innervation. So that's what they did. Rabies virus-based retrograde, all of this stuff. So this project was funded by DARPA. Hello, GM Asari, thank you so much. That project was funded by DARPA, is what it was funded by, and other private organizations. And I wonder what happened to this. I'm trying to look up here. I had the tab open, and it got rid of the tab that I had for some strange reason. It got rid of it, but it doesn't matter. Okay, it really doesn't matter. They mapped the brain. Hello. Yes, thank you, GM. So they mapped the brain, and they wanted to know how silent was the brain. And here's what they compared it to. They said the brain, because such neurons would be difficult to detect with the most common method of monitoring neural activity in the viveo extracellular electrode recording, they could be referred to as a dark neuron in analogy to the astrophysical observation that much of the matter in the universe is undetectable or dark. So that's what they wanted, the dark matter of the brain. Now, why do they want to go do that? That's what you got to ask yourself. Why did you want to fund a project of brain mapping the brain? That's what the guest speaker said in that video that, by the way, I turned off the comments because there were some not so nice things being said. And if I don't like people saying not so nice things about me, I think that would be very hypocritical for me to allow people to say not so nice things about someone else, because I'm no better than them and they're no better than me. We got to speak nicely and peacefully to one another and with love. So I disabled the comments because I got on there. I thought, oh my gosh, that's not very nice, even though you may feel that way. I disabled it because if I don't like it being said about me or someone else, I really shouldn't have allowed it on there. So that's why the comments got disabled. But we are talking about dark matter of the brain, okay? Dark matter. So they've had several years to do this. So they mapped the brain. This was also, look, syringe injectable mesh electronics integrates seamlessly with minimal chronic immune response in the brain. You say, Gina, what are you saying? I'm saying that they have taken a syringe and they can, you know what a mesh looks like? Just say like a net. Well, they have made a mesh that is able to be injected in a syringe and implanted in your skull. Okay, look at this right here. We're going to see this right here. This is just a little bitty video of these scientists. I think it's at Harvard. We're going to look at this, you all. I'm going to flip it around. I'm kind of nervous. Let's flip it around. They've got it going right here. Watch this.
Load the mesh electronics into a needle. Insert a glass capillary needle into the 100 milliliter beaker of PBS containing the mesh electronics. Position the end of the needle near the input-output pads of a mesh electronics probe and manually retract the syringe to draw a mesh electronics probe into the needle. Push and pull the syringe plunger while it is still immersed in saline to adjust the position of mesh electronics within the needle.
Look, they're going to inject it into a mouse. Okay, that's it. We don't need to watch them drill a hole into the cranium of a mouse. But you do remember that Mr. Musk said we need an interface right up here so we could be connected to the World Wide Web. Well, this is a brain interface. This mesh can act as an interface, and it will fit and it will absorb. It will just fit right in with your brain. So they put all that money to study in the dark matter of the brain and the neurons and stuff. And then they got this mesh that they can put in your brain. It really doesn't even hurt. You won't even know it. You won't know it. Look at this. There is good and there is bad to all things. They say the treatment of neurological disorders such as Parkinson's disease, that would be good. And the demonstration of the brain-machine interface for advanced prosthetics. A brain-machine interface with this mesh. That's what they can do. A brain-machine interface. Well, these people got it going. They got it going. This is scientific research at its best. They've come a really long way. They really have. And it's so flexible. This mesh is flexible, more flexible than anything you can imagine. They say flexible probes. I can't even say it. The flexible probes are made from 10 to 20, I don't even know what it is, thick sheets of polyimide, 100,000 times stiffer than brain tissue. So yeah, I don't know what it can do. I don't know what's going on with that, but they have done it. They mapped the human brain. And they've had 8 years now, or 7 years to get it down. And that's what's in the new thing. Okay, you know it's in it. Look at this. Nanotechnology is what it is. Nanotechnology. So yeah, neuroscience. And here's the name of it. The Brain Activity Mapping Project. 3 goals in the terms of building tools for neuroscience, measuring the activity of large sets of neurons in the complex brain circuits, computationally, I can't even say it, analyzing, modeling these brain circuits. They're going to model the brain circuits and testing the models by manipulating the activities of chosen sets of neurons in the brain circuits. So they're going to manipulate certain sets of neurons in your brain circuits. That's what they're going to do. Oh my God. Oh wow. It's a photonics-based probes with multifunctional capabilities, synthetic biology approaches. Yeah, so you all, I'm telling you what. So let's hope that this right here, well, we know that this right here has some nucleoside modified messenger RNA encoding. So that can go in there and send out a little coding of its own. So that they I don't know you all, but that's what they've done. They've mapped the human brain. And yeah, that's what they did. They mapped it with that project that was set. Yeah, mapping the brain, like the guest speaker said, mapping the human brain. It does sound silly. It sounds so weird and so far-fetched, but it's not, you all. It's been mapped, and they've come a long way. They've come a long way. You can say no. You really can. Look. Dark brain, the graveyard keeper. I don't like that. I don't want them to refer to my brain as a graveyard keeper. Do you want them to refer to your brain as a graveyard keeper? Yeah, transhumanism. Well, China, or was it France, has now passed whatever to make their soldiers transhuman, like so they can be stronger and better. Yeah, but you know this technology has been out for a long time. It has, and I didn't know. I didn't know what I was going to share this evening, and I just had to be silent. Look, yeah, here's what they called it: the human Connectome project. I've never heard of that, but that's what they did. How close are we to complete a map of the brain? I think they're already there. I really do. I think, whoa, that's pretty. Look how pretty that is. Is that not pretty? Oh my gosh, that is so pretty. Navigate the brain in a way that was never before possible. Fly through the major brain pathways and compare essential circuits. Zoom into a region, explore the cells that comprise it and its functions that depend on it. The Human Connectome Project aims to provide an unparalleled compilation of natural data, an interface to graphically navigate this data, and the opportunity to achieve never before realized conclusions about the living human brain. Wow, they chose some really pretty colors, didn't they? They did. You've got to laugh at this, but it's really not a laughing matter. This is real world. This has happened, and it is happening. It's happening. National Institute of Health praises the Human Connectome Project. That's what they've done. They've praised it. Yeah, it is crazy. But guess what? They want that neural face. They want that interface. They really do want that interface. And I heard that I think China's going to do that with their soldiers. They already got this equipment that their soldiers can be super soldiers, some kind of bio something, robotic stuff they put on their exoskeletons. Yeah, they can carry their whole entire weight with this exoskeleton. It really helps them travel light. Yeah, so they're making their people wear stuff like that. But yes, this has gone far. They map the brain, and you have to think, why would they fund a project to map the brain unless they want transhumanism? Yeah, so transhumanism, it's here. It is here. And it's becoming mainstream. It is. I don't want to be a transhumanist. I don't. But with nanotechnology, it's going to make everything possible. It is. All of these things. The Great Reset, I've heard that the Great Reset, Sustainable Development Goals to build back better. And this is, yeah, all of that, you all. There's so much stuff going on. And I don't like to get into it all because, you know, there are pros and cons, and there's people who are for and people who are against. But we all like our freedom, and we all like our autonomy. We do. We all like to have it our own. But it may not be possible one day, and that will be a very dark day to live in. It really will. In the meantime, that's really pretty. That's really pretty. So, I don't know what they do there. Laboratory of Neural Mapping. That looks kind of neat. Look at that. Neural engineering. Oh, neural imaging. Yeah. What is their gallery about? Oh, they got pictures of the brain. Look at these, all these pretty pictures of the brain. Genetic discussion.
Random diffusion.
No, I'm not going to watch that. That's a YouTube video. I will not play a YouTube video on here, but you all get the thing. Yeah. So that's what they've done. They have mapped the human brain, just like the guest speaker said that they were going to do, and the audience laughed. He said, "I'm not joking." He said, "I'm not joking." They did it. They did it. Yeah. So I know this isn't a UFO video, but it, you know, there's robotics. Oh my gosh, this is AI, is what it is. Yeah. Well, I couldn't believe that they could literally inject. They could make this. They use live animals as guinea pigs is what they did. Look at that. They started off with something like this, is what they did. Put it in machines, and then they put it in a needle, a syringe right there. Well, that's the glass beaker, but then it's in the syringe right there to be injected into the head and as a net for an interface. Brain interface. Well, that's about all I've got to say. It really is about all I've got to say. I was going to do a live nano. The Brain Activity Mapping Project is what it was. The Brain Activity. Wow, look at this. It says, it will focus on dynamic voltage activity and on chemical neurotransmission with an estimated 85 billion neurons, 100 trillion synapses, and 100 chemical neurotransmitters in the human brain. This is a daunting task. Thus, the project will start with model organism neural circuits. And so they said this is a what would they say, a daunting task, but they did it. They did it. They had all these other companies working, I guess, and sharing their data. So yeah, it's happened, you all. And with that being said, I am going to go. Thank you all for coming on here. Yeah, yeah. I don't want it pushed on me. I don't, but that's what happened, you all. I heard that there's going to be the old humans and there's going to be the new humans. That's what I heard. You'll have old humans and then you'll have new humans. Yeah, so let's flip this around. I am going to go. Thank you all once again for tuning in. And we'll look at that pretty color right there because I think that's so pretty. At least that's one thing to look at. Have a wonderful rest of your day. Thank you all so much. Thank you.